to the cure, living on the edge. Driving at a velocity of speed McQueen, you're always living on the edge.
how do I want to design this? Let's just do it with a V-carve. Let's say, V-carve additive? No. V-carve pocket, right? That's what it should be. Let me go look this up. So, SBF. I think I should have a thing called V_P, which is for a pocket. But it's a V-carve pocket, so the path itself has a width and a height. It does not have a thickness. Okay, yeah. When did I think that it had a thickness? I don't know. Let's create a lug rect. So this VP thing. Oh, I see. This takes a thickness, but we don't actually support thickness. I see, and that's why. Yeah. Okay. So the units here are in terms of lugs, right? So I'm gonna just take this. And if we're using this code, then a lug rect, we're just going to say lug rect, LR, right? So it's, because this is the type of function we use for the laser cutter. We're going to use lug rect because the assumption here is that these dimensions, we just want we want to, if we use this function, we want to So we're going to do this, right? We're going to bring back the lug rect functions that we've been using. Let's just call this 1616 because that amuses me. We're going to bring back the lug rect function names, right? But when we're doing shopbot code, the signature for a lug rect is going to be different than it usually is because the first parameter has to be this like LR, this SBC param, right? So SBC and then the width and the height. We're going to keep this because this is actually quite useful, right? And then also I think I would like to keep the lug rect, the lug X, lug Y commands as well. So a lot of the functions that I've used before, let's just try to keep that, right? So translation, a lug X, lug Y, oh, we already have it, right? So that's cool. Very cool. Okay, so we got that. So in here, I'm going to just turn back on the music and start working off of my blueprints. But basically, I want like a table, and this is a piece, this is a piece, right? So all these brackets are different, are graph paper pieces that create the shape. So very primitive shapes that are going to create a frame that's going to encapsulate a 1 foot by 1 foot piece of wood, right? So each of these squares is 2 inches, right? So if there's 6 of them, and they're each 2 inches, then 6 times 2, that's 12, right? So a 12 by 12 piece of wood is going to fit into the middle there, and that 12 by 12 is going to be the ZODIAC table or any other type of inset. And we want to design this so that there's a little bit of a gap We want to take advantage of the gap that's going to be between the top and the bottom of the frame, because we're bolting it together, and we want to use that to make a false bottom to the table, so you can like stash stuff in it, right? Like, well, let's take advantage of some of the oddities of how we make things. Anyways, I'm gonna find some other music to listen to, because I've been listening to this same track over and over again. Let's just find, I don't know. Let's go Windows E, and let's go find our music folder. So let's go music folder. And the thing is that this stuff gives us copyright strikes, right? If we listen to this. So we should probably stick to, just, I don't know. Well, I do like XRX. Let's just listen to this one song and, I don't know. Let's focus. upstairs and check how thick the material is I'm going to be working with. I think it's like a half inch or no, a quarter inch, but I got to know. I absolutely have to know. So I'm going to start a timer because that material thickness is going to be paramount to everything else. So I like the wood I picked out. So I'm going to use that wood. I'm going to base my calculations off that wood, but we have to get back to reality, right? We have to base our calculations on reality. So we're going to go take our measuring tape, go out there and figure that out. Okay, as I suspected. Oh, I need a sweater. It's fucking cold. Okay, so 5/8 material. It's 5/8 material, which, oh boy, that's weird to work with. But that's what we're working with. Okay. That's fine. I don't want to listen to that track. Let's go. Not sure when I'm opening that. Okay, I'm gonna try to keep on going here.
go gently into that good night. Old age should burn and rage us a day. Rage, rage is the night. 1, 2, and it was after you. 3, 4, he's really just like you. 5, 6, the darkness is the beast. You close your eyes to see. And wait, the fire that possess you. You swore you never give it up. I'll take every night away, away. Just
WTF, what the fuck? Why is that not looking good? Oh shit, yeah. Quickness, duh.
This not go gently into that good night. Old age should burn and rave us today. Rage, rage, is the dying. 1, 2, the devil's after you. 3, 4, he's really just like you. 5, 6, the darkness is the beast. You close your eyes to see. Embrace the fire that possesses you. You swore you never give me up. I'll take every night and lay away. Just promise to stay away. I These evil player, do they know so much just like me? They understand what I'm saying. I wish I no more blame. Cause we destroy what we love. Cause we destroy the smile and the soul. Cause we destroy what we love. We're selfish, I'm not very much. Innocent number, they say goodbye. Don't let me now with a heart attack. I know myself, I did some wrong. But I'm not ready yet to be bored. I got a face, reason to fight. No, I'm just joking my mind. I got a face, I got a soul. But now my heart just wants to stop.
Okay, so the thing is, for this kind of stuff, it's not the same as how I usually do this on the laser cutter, because not only can we have different layers, but we can have top and bottom surfaces, and these sandwiches might be asymmetrical. So, instead of a thing called wick, right here, we're going to, let's rename this as _.fab. And a fab is going to, will not have a fabrication will not have a one-to-one relationship with a part. So fabrication may take multiple parts and extrude them appropriately and all that stuff. So like a lasers so we're going to create a thing called fab, and fab is going to be a thing only for shopbot stuff. It doesn't apply to lasers. Okay, and okay, so this right here, at this timestamp, what we're saying is fab is kind of like a glue module. Is like our glue code and sandwich code, but mixed together. Because some of the complexities of how we're going to create fabrications, how we're going to put together all the layers, it just doesn't make sense to have glue and sandwich code separate. Okay. So, the extrusion code, let's go look at the extrusion code. I don't think we're going to do extrusion code like this. We're going to be extrusion code is going to be one layer at a time. Or actually, there needs to be an extrusion payload that tells us what to do. And the extrusion payload is going to have the component ID. It's going to have the component layer index that we're trying to extrude. And, what else? I don't know if it has anything else besides that, right? We could try to make that more complicated, but, like, we could also have it be recursive, where it tells us, there's multiple parts that need to be glued together, right? We could, but once again, the glue stuff is in fabrication, right? So we need the component ID and the layer index for what we're going to extrude, right? So in extrusions, right, instead of doing this, we're going to do, we still need the shopbot constants, right? But we're going to give it an extrusion payload. Okay, so instead of like trying to figure all this out, right, we're just going to give it a thing called an extrusion payload. And, right, so instead of this latex, we're just going to give it an ext payload. And then what we're going to do is ext, right? It's shopbot constants at ext payload, so se, right? And then this thing here, right? Instead of this corner, right? This corner, we're gonna make a thing called corner top and corner bottom instead. So in our code where we originally had this thing called corner, we're going to change that to corner top, right? So so anywhere we see core, we're just gonna rename that to corner top. And then we're gonna break this apart, right? So this is corner top, right? This is plus, and this is corner bottom, right? So corner top, corner bottom, and we need to give it a rendering settings object, right? So it's not gonna take a fab object, it's gonna take a rendering settings object. And this is zitcom corner top. And this is the corner bottom, right? And instead of having this latex thing, we're gonna get rid of this, right? We're gonna nuke this. And this is just gonna take a long time to figure out, but cot corner top. Okay, and then this thing is going to be this piece, right? Each of these modules are going to be each of these components are going to be in terms of like pieces that are glued together and finished, right? So this is a corner bot layer, right? So these are opposing pieces. They're different pieces, right? If we got this like in an IKEA model, cot and cob are two different things. So we're breaking a lot of stuff, right? So zit e core. So in the extrusions, we have cot, and then there's no core, right? So there's corner top and corner bottom. So we could do cot and cob. But that doesn't solve the fact that there's no zit e core, right? So where is that coming from? It's probably coming from here, right? So corner top, and this is this thing is corner bottom, right? Okay, unknown variable e, and I don't know where that's coming from, but I guess we'll have to find it. I have no clue where that's coming from because I just been throwing together some code. And now I'm losing track of where things are. Great. So that sucks. Because we don't even know where that is coming from, right? There's an unknown variable called E somewhere. Like, just hanging out. For whatever reason. And I have no clue. Oh, this variable here. Okay, so when we're doing this extrusion, the extrusion code is going to take, once again, the component ID. It's going to take a payload that has the ID and the layer index in them, right? Okay. So it's going to take like a extrusion payload, right? So the extrusion payload, right, should be this ext, we'll call it an ext thing, right? Extrusion payload. So SE, S and E. But we're not going to be able to one-line these, okay? Screw this, we're not going to be able to one-line these, it's just too much. So, shopbot constants in this ext thing, right? And these are just wrappers, right? These are wrappers. And we use the ext with SBC and the ext command. And it wraps this component, right, SBC, with the rendering code. Or not. So we can't really give it the so not even that. It's just like this. So zitcot ext, it just takes SPC, right? SBC. And this just takes a certain pre-configured payload. So actually, this takes zit ext, right? And it takes ext, takes SBC, but then it takes zit ext, right? Or it takes the extrusion code it takes a special object. Okay, so we could do it, we could one-line it, right? So cot, cob, and mid are gonna take a special extrusion object, though, right? So they're gonna take some extrusion. They're gonna take an extrusion settings object. And if we do this, this object name is the same as this, though, so that's a problem. So let's make it all lowercase, right? So here's the thing. This is private, right? This is a private settings object, whereas this is a public function, right? Or that's the way we're going to think of it. And then in here we have to say, you know, zit ext for this equals some type of object. And the extrusion settings for this, what do they tell us? Well, the first thing is going to be 0, right? And then the next thing is going to be the model index, right? So the model index is going to be like in our main file here. We need to create an index of models, right? So so this model index thing right here. Let's take this out, right? And let's include, after components, let's include a thing called include mod. Okay, we'll call it model indexes. And in here, what we're going to do is we're going to enumerate, identify components by model index. Right, so identify, well, we're going to identify the components by model index. And a lot of this is just hackish because of the functional nature of OpenSCAD code, where we don't have much flexibility, so we just have to, it's like a little puzzle. So cot is going to be the cot, the corner top. Cob for the corner bottom will be 2. And then mid for that middle model thingy, whatever the heck, right? And let's get rid of this. I don't know what that's about. But then what we're going to do is we're going to have a thing called zip mod, or module. Zip mod. And it still takes SVC, right? Everything takes SVC. And then it takes the mod dex, right? To know how it's gonna, like, what it's gonna render, right? It's gonna take the model index. Okay. And the model index, now we could say that mod index comes first, right? Because it's mod and then it's the model name and then it takes SBC, right? So model index, right? So it's like an object. So this is like a object orientation pattern, right? So zip mod this is the name of the model. So zip mod, this is the name of the model, and then it's just a wrapper for the other model functions, right? So in the components, right, we have like these components. They take SBC and a render, right? So it's just like this, right? But then, and this looks like a disaster. Everything is a disaster here, right? Because we've never done this like this before, and so now it's just like a disaster. So, okay, so if mod equals okay, and the render settings. So it's just it's just a little lookup table, right? So alright, so these are mod dex, model indexes of different components. Alright, so I have this little indirection so that we can kind of make this, so _.mod. Okay, and then, you know, if it is this mod, zip mod cot, right? If it's this guy, then we're going to call the component SBC with the rendering settings, right? So we're still so this thing is still going to take the render settings like that, right? So depending on how we want to render the geometry, do we want to render what layer are we rendering the are we rendering the body? Are we rendering the subtractive geometry on the top? Are we rendering the subtractive geometry on the bottom? Are we rendering the through holes, right? So we might also want to make a render thing as well. So let's close this off for a second. Okay. So when we're rendering things, we might want to codify that. Now, we were codifying it over where? We were codifying it over here, right? So rendexes, right? So we're thinking about layer index. Layer index is too complicated, right? So we don't really want this. We want more like this is close to what we want. But instead of like this, I'm thinking we do rendex, right? And this is top level, right? Rendex is this is a contract that like all shopbot models need to abide by, right? So that's a big thing, but right. So the additive body, the subtractive top, the subtractive bottom, and we're missing something, which is the subtractive through holes, right? So rendex sub through I'll just call it punch through, right? We'll call it punch through, right? So we have the top features, the bottom features, and the top and bottom features are bores, and then number 4 is punching, right? So we'll just call it rendex because that'll make it easier when we're looking at things. So this is rendex here, right? And so we call this rendex, right? We can call this right here, we can call this rendex. So when we're rendering it, we use rendex, okay? And then in the mod code, right, we have the moddex and the rendex. And we might want to make a note of that, right? So that, you know, moddex, so how are we doing this? So the reason we're going to call this mod rather than component is because we already have the component namespace for the 2D versions, right? So I mean, I guess we could call this zip.com, and then it takes a thing called com. Oh, but then these enumerations, right? These enumerations would collide, right? Because zip.com is the actual function, while zip.mod is the enumeration, right? Or we could just call it or we could just do this. We could just call it comdex, right? We could call it comdex, right? Instead of having a model folder, right, we could do comdex. And then this could be the component, right? This could be comdex. And then there's less confusion, right? Let's not use a mod dex to identify components. to render, let's just use a thing called comdex and place it at top of the less confusion and mental indirection. So I don't think so instead of model index, we're gonna identify it by component index, right? So we're gonna just give some type of enumeration that can render the model, right? So this zitmod is now going to be called zitcom, right? So it's the generic version of the functions, right? Okay. So then this thing com right here, and then so this, instead of this being zitmod, this will be zitcom cot, and then it renders this, right? Takes these two parameters. So render mode, right? So render mode, and the render mode is 1 equals, right? And if we go over here, right, we have this is additive body, right? So 2 is going to equal, we can reference over here, right? We're gonna make some copious notes because this is the first time we've done this. Subtract the top, right? So this is boring in, right? We're boring into the material on the top. And then 3, the render dex is going to sub from the bottom. So subtract the bottom, and we're not going all the way through when we have the subtractive top and bottom, right? To go all the way through, we're going to have a thing called rendex sub pun for punch through. Punch through. Okay, so now that we've made these little wrapper functions, let's duplicate this a few times and just steal these. And then let's also make sure we haven't introduced any horrible syntax errors, because if we introduce any like horrible syntax errors, it can be very hard to figure out where the hell that came from, unfortunately. Like right now with OpenSCAD, like I have no clue where we have destroyed the code. Like right now I'm looking at the code, no clue where we went wrong. So we need to absolutely make sure that we do small incremental changes, because if we don't, we end up with this situation where we don't know what we changed, and we introduce some type of fatal mistake into the code, and we just literally do not know what we destroyed, right? So the first thing we can do, I guess, is to try to recover from here, is to just comment all of this out and say maybe the mistake is in this code we were just twiddling with, but it might not be, right? So if we do that, line 34, like line 34 where is this line 34? We have no effing clue where this is. OpenSCAD is a pain in the ass sometimes. So what we're gonna do first is we're just going to start commenting some stuff out, right? So we're gonna comment out some of these includes, and we're just gonna we're gonna close this, right? We're gonna close it and we're gonna reopen it. Okay, we commented out a lot of those includes, and what we're hoping is that, okay, line 34 still have an error, right? So it's like where is I have no clue where that's coming from. Now it could actually be line 34, but yeah, not this line 34, right? A line 34 somewhere in one of these files. So maybe if we're lucky, it's like a line 34 in one of these files that's included. But even then, that's like that's a stretch. So we can keep on trying to comment stuff out, right? We can try to comment out the component file, and then we can try to go F4, and we're still getting some type of mistake, right? So it's still saying, hey, you're full of it, right? And it could be this. It could be this file, right? Maybe we edited something in here, and we screwed this up, right? It could have been this. But we are in a world of hurt right now, and we should have never done it. We should absolutely not have done this, but Yeah, like where? Like what WTFs, right? So I'm gonna guess, like, it looks like maybe it's actually coming from here, right? Now, the way we could probably figure that out really quick is we can just go to our previous model, right? Here's our previous model. If we try to open this, if we open this and it's still, sorry. If we open this model, and it also fails on us, then we know kind of where the problem's happening, right? So, oh, 160. Okay, so we actually we've screwed up the SBC file, right? So we've definitely screwed this up, and something we've done here has introduced some type of syntactical mistake. And guess what? I don't know where it is. So... Oh my god, I have no clue. Like, I'm looking at it. I'm looking at... Oh, shit, look right there. Right there. Right there. Look at that. Okay. So now, if we do this, F4. But yeah, we need to be very careful, right? This is very fragile. And this is the whole reason why I like to not have some type of big reusable file in all of my different OpenSCAD projects, and I tend to cut and paste a lot because, right, we make one mistake here, we have absolutely no clue where the mistake is, right? And then we have to, and then it can destroy all other files. It can destroy all the other files that are using this reusable piece of code, right? So, reusability is not like is not a, what do you call it? It's not a magic bullet, right? So, leverage works both ways. So the ability to if you have a lot of leverage, that gives you the ability to be highly productive. It also gives you the ability to be highly destructive, right? So we make a mistake in this file and we use this file everywhere, then it gives us the ability to destroy multiple files rather than just one. So anyway, so let's go F4 here. And okay, unknown module. So we commented out a lot of stuff because we were trying to figure out where the heck we made our mistake. And so now we know where that mistake was made. So let's try to comment kind of the code back in. And let's hope that we didn't make any other egregious syntax errors. Like egregious syntax errors to where, so unknown modules is not as bad, right? Because we can go into the files and we can kind of figure out where that's happening, right? So for the extrusions, we have a plan for how we're going to do these, right? Like, so we're going to have like an extrusion payload, right? And we want to know, or do we need an extrusion payload? How are we going to do this? No, we're going to only extrude one piece at a time, so why would we need an extrusion payload? Why not just call, I don't really think we need such an object. Now let me check my notes and see why I was thinking I would have some type of extrusion configuration object. This is the wrong notebook. Or is this... Oh, this is my piece of paper here. Okay. So we gotta, like, extrude the body, extrude the subtractive features. No, I don't think so. What we really need is we really need to know the model index to make this work in a procedure. So this kind of extrusion wrapper isn't going to be like this. It's going to be more like ext. So ext, and I think we're going to keep with the code that we're going to keep some. Okay, so first of all, let's move this. Let's make sure we didn't introduce any horrible syntax error. Okay, so we got some problems. One step at a time. So in our components, we're going to throw this in here, right? So we're going to identify the components by a component index, right? And a lot of this stuff, we're just going to have to pass around numbers for, like, that act like enumerations. So we have component, we have the shopbot constants, and then we have the render settings, okay? And we're just going to make a lookup table for these different models, right? So if this component is not this thing, right? That's a function. So if the component index here, right, is equal to component index is shorthand for this, right? If ren is shorthand for render model, mode. So component index render mode, right? So if the component index is the index for this model, then we're going to call that model's rendering function, or that, right? If it's number 2, if it's number 2, then the corner bottom model is what we're going to render, and we're going to give the shopbot constants in the render object, right? So we're doing an object-oriented pattern in a procedural. No, we're doing an object-oriented pattern in a functional style language, right? So this thing here is kind of like the object, right? This is the object that is usually implied when you're doing object-oriented programming, right? So I decided to put this first, even though usually everything, the first parameter is always this SBC thing, right? But it's like we're going to, what is it, shift or unshift? I think it's shift, right? So shift direction. You know, you think I would have a shortcut for this, because my old boss, like, got on my case for not knowing shift and unshift, but I never use this terminology. Unshift direction. Shift versus unshift. Did I at least make something for that? Did I not? Yeah, so a shift is... So here's the shift, here's a push. So shift and unshift over here, push and pop. So shift and unshift apply to the base of the array, where push and pop apply to the tail, right? So shift. Is shift putting things on? Okay, so if we have an array and we shift it, yeah, it shifts things off, right? So shift grows the array, unshift shrinks it. Yeah. So okay, yes. So shift direction. So shift direction. This way, it pops off the head. Right, so shift is basically going in this direction, right? And that's just weird, but yeah, shift goes to the left, right? Oh, that actually makes sense, because, right, the shift operator, but you can go shift left, shift right. That's why I don't like shift and unshift, right? So then unshift, this pushes onto the lowest element. Or you could say pushes onto head, right? It pushes onto the head. Okay. Whereas a shift pops off the head, right? The head being the 0th element, right? So lowest index, right? So here, pops right, really, let's abbreviate this, right? This is basically what it does. It push, right? So unshift goes like this. It pushes onto the 0th index, where unshift pops the 0th index, right? So push and pop. So push and pop operations happen on the tail, right? And when I say the tail, I mean the highest index. Pops the head, and this one pushes the head. Pops off the head, pops on the head, right? Anyways, so when we're looking at this, basically we're going to, according to this terminology, we're going to take this and we're going to shift this parameter off. And then when we shift it off, we only are left with SBC and ren, right? And that's this, right? This is basically the same stuff, but with this part shifted off, right? We're trying to whittle down the parameters as we go. I don't know if I'm making any sense at all. Anyways, I'm going to take these notes here for a second. And this just is kind of chaotic because I'm trying to set up a kind of a rendering pipeline for how to assemble these objects. And I need to make it so that from my 2D blueprints, I can make the 3D assemblies, right? So I can, so if I do this correctly, I'll have a 3D assembly, and I can verify the correctness of the final assembly. And then when I go to cut the pieces, I don't have to worry. I know that it's going to, I absolutely know it's going to fit together because of how I coded everything. But unfortunately, that just makes things very complicated sometimes when I'm trying to figure out how this system needs to be. Okay, so right here, we're going to identify components by component index. And this is the pragmatic way to invoke different components, right? Like this, what this is right here. Pragmatic component invocation. Oh god, that is a word. That's wordy. That's wordy, but that's what it is, right? So right here is the pragmatic component invocation is what this section is. So let's see if we can kind of section this off and organize it a little bit better, and then we'll move on to the next kind of part here. So already I'm like, okay, we're a little bit too verbose. So it's like, okay, well, we have to call it comdex, because if we call it com, then it's going to collide with this, right? So it has to be named a little bit different. It has to be named a little bit different, right? So I'm fine with it being like that. It might just be that, you know what we can do? We can just make some shorthand variables and simplify this, right? So S equals SBC, right? And then, R equals, ren, right? And then if we're going to have this much indirection, why don't we just simplify? If we're gonna, let's not have 3 different layers of indirection, right? Let's make this a little bit bigger, right? So that we can just put this here, and then right here we can say, oh, S and R, right? It takes the shopbot constants and takes the rendering stuff, right? And then boom, we have these nice little wrappers, right? And now we're not going over our column limit. Also, still not the best. Oh, also the component. So C is for component. So this could be comdex. Right? So SBC is the only thing that doesn't have... SBC does not have a 7-letter form, right? Because SBC literally stands for shopbot constants, right? So shopbot constants, right? Or you could think of it as a configuration object. And this thing here is the component index. So I know I already kind of like explained it, but I'm going to explain it again because I have room here to render actually rendex is wrong. Render mode. The render mode will be an index, will be a number, but it's yeah, it's not called rendex, right? Not rendex. Not rendex. Rendex is wrong. It's not called rendex. My bad. Ren mod. Okay, so we have the comdex. We have comdex, we have SBC, we have the render mode, right? And if we really want to break this up a bit, like, we have this kind of explanation here. Why not make a nice little exploded parameter list like this? Like, if we're really going to get this complicated. And just put the explanations by this, right? Like, maybe that would make more sense, right? To have this, like, here. Identifies component in render, right? Right, so identifies component to render. These are the shopbot constants. Right, so, we don't want, if we want to know, like, okay, how many internal units is 1 inch, right? Well, the shopbot constants will tell us that. For our custom unit called a lug, which is a large graph paper unit, how many inches does that factor to, right? Shopbot constants is going to tell us that kind of stuff. Render mode. Render mode is going to tell us, well, this stuff right here. We have the information right here, right? So render mode. What features to render? So render mode is not used in the sense of like a rendering engine, right? It's not quite like that. It's like a it's more like I don't even know what to call it, but it's the geometry to create. I don't know what to call it. Okay, so we got Comdex, we got SBC, we got RenMod. So C, S, and R. And then if com, right? So this is going to be C. So here's the shorthand Comdex, SBC. Here's the render mode, right? Okay. And what I'm hoping for here is to eventually I don't have enough room here, so we're going to just say zitcom dex min. Okay, and then we're going to say, like, zitcom dex max. Okay. And then what we're going to do here is we're going to just have a way to check this, right? So we're just going to say, you know, if the comdex is if, well, first of all, if not comdex greater than or equal to 0 or comdex less than or equal to 1, right? If it's or less than or equal to 0, right? If this is not true, then echo comdex nan, right? Comdex is not a number, right? So we can just say zit, right? So this is so this is zit.scad/_.com, right? So that's how we're namespacing it, so we can find it later. But yeah, the component index is nan, right? And then if comdex is, if we don't get that error, if it's less than this min, then we're in trouble as well, right? So this is, you know, echo let's just take this and be like, you know what, this is namespaced pretty well. Why don't we just steal that, right? So why don't we just echo that the comdex is less than this min, right? We can just literally let's literally steal that and echo that problem, right? And then copy this. And then if the component index is greater than the max, then we also have a problem, right? So let's just put that there, right? So so we have an input checking, right? So input checking, right? So we want to be able to check the inputs because OpenSCAD is very error prone. If we screw this up, we're going to be in a world of hurt. So we want to get this good. So okay, so if we do that, F4. Okay, well, we're okay. We're not in a horrible place because, yeah, we got all these warnings and nothing's working, but we don't have a syntax error that's really blowing us up. As long as we're not really blown up with syntax errors, we're going to be okay. Okay, so now for this component, in the extrusion code, we want to figure out how the heck are we going to do the extrusion code, right? So, I'm thinking that the extrusion code needs to use the same kind of style of thing here, right? So it can use the same component index to know what extrusion type thing we're gonna use, right? So let's go look at com, right? So we're gonna take this kind of a thing here, and we literally can take we literally should be able to take this this, right, and go into the extrude. And let's just, some of this stuff just needs to be nuked. Okay? And we're gonna say, okay, pragmatic, why is this indented like that? Oh, I see. Well, first of all, use okay, so we're still going to use, so for this extrusion, we're going to use, we're going to call this ZODIAC. We're going to take the same exact parameters, right? So this is a generic extrusion kind of a thing. And, right, we can just say that zit.scad / instead of com, it's going to be ext, right? We might want to make a note of what file this is coming from. Right? And what we can do now is we can start to figure out how to render this, right? So we can say, so these things here, right? This is kind of like zip ext. We'll figure that out. We're figuring this out, right? So we're not going to do it like this. We're not going to hard code this. We're going to say, these wrappers here, right? That take SBC, they're just going to be so here's this thing, right? So in the ext thing, it's going to be like let's just hard code that component index, right? So this SBC and then nothing. Oh, because the render mode so we're gonna whittle off the render mode here, right? So really you just need the component index that we're gonna render in the SPC object, and the render mode gets cut off because it's going to be, yeah. So then for this, maybe we have room to use the whole thing since we don't need the render mode. I don't know. So let's look at the component things again. So we take all of this and we put this over here. Instead of hard coding that as a 1, we could do that because it just takes SPC. Right, okay, there, and then we got a nice little wrapper, right? So we got this thing, and let's put a semicolon at the end of this, and let's do this, and let's just make sure that there's no horrible syntax error where it's going to explode. Okay, that's fine. Okay. So these three variables, right? So we have the corner top, we have the corner bottom, and then we have this mid thing, right? And these are the parts that we have, right? So the components that we have, and components may have, I mean, technically, components may have different pieces of, components need a layer index as well as a render mode, don't they? Because there could be multiple components have multiple layers usually, right? So for now, let's try to think that the pieces here are only one piece of wood, right? And let's not worry about multiple pieces of wood stacked on top of each other, right? That might be more complexity than we need, and we really need to just get this kind of working first before we add on even more complexity, right? So so these wrapper functions. This is the extrusion code. This is just an example of how this would work, right? We don't actually, we're never going to use this, actually, because everything needs to be, whatever, let's not worry about that. Okay, so F4, unknown ZODIAC cod, right? That doesn't exist anymore. Okay, so in here, we came up with some logic for how we're going to do this, right? So we're going to do a difference with a union operator. Okay. Okay. And the additive geometry goes here. So additive geometry right here. And so we're just going to say zit ext extrude body. Okay, so we'll call it extrude body. And we'll give it the component index. So this is the model that we're going to extrude. We'll give it SBC as before. And then we need to give it the... Do we need to give it the render index? No, because we already know what the render index for that is, right? Because the render index is going to be the body index for extruding the body, right? So we can say SBC. We can use comdex, the component index, and the SBC, right? And then when we're extruding the body of this component, we're kind of assuming that the component is one layer of wood thick, right? For now, let's not worry about multiple layers of wood right now. Let's just get the basics done. Okay, so then what we want to do is extrude subtractive features, right? And we'll give it comdex and SBC, right? Extrude, let's keep this more shorthand. So extrusion additive body, right? This is extrusion subtractive, and it is the top, right? So we can pour this all into one thing, right? right? And then we also want to combine it with extrude these subtractive features bottom, right? So we have, if we don't carve all the way through, right, then we have bottom extractive, then we have one more thing though, right? So we have the subtractive features on the top and bottom, but we also have the punched through features that go through both the top and the bottom. So zit extrude subtractive features pun for punch through. Okay, now let's make sure we haven't, let's move this away here. Okay, so right here, let's kind of like, let's throw this in here like that. This is craziness. Okay, so extrude additive body, right? And then this right here is extrude all subtractive geometry, right? And then we difference them, right? So we difference the, also red mod needs to be set. No, it doesn't need to be set here. So right here, Boolean together, final panel geometry, right? So final panel geometry, right? And this is what we need to do. Okay. We're not going to worry about the different layers, right? We're not going to worry about the different layers yet. We're going to just worry about getting this working at this level of abstraction, then we'll figure out the next thing, right? So we've done stuff like this before with the laser cutter, but the shopbot allows us to do a little bit more, so we have to account for that. Okay, so that's cool and all. What next? Well, we're also going to have to make sure that we remember that the bottom will require flipping over the model. And so when we want to render just the bottom, for cutting blueprints, we're going to need to remember to flip them. But for now, we're not even going to worry about the mirroring aspects, right? The mirroring aspects will be handled by the cutting sheet code, I guess, right? We'll have to have more advanced cutting sheet code as well. There's a lot of more advanced kind of code for how we're going to piece all this together. Okay. So now we have this extrusion stuff, right? We need to know what to do here, right? So we need to say, okay, so module, right? Zit ext add body, right? And it takes a component index, right, to know what it's going to render. And then it takes SBC. And all we got to do here is we're going to linear extrude it, right? We're going to linear extrude it. We're going to steal some of this code. Let's create a, okay, so the linear extrusion for the body, we need it to be the material thickness, right? In imperial units for some reason. And we're not going to move it, right? So the material units and imperial material units, okay. So let's steal that. God damn it. So this isn't even correct because this is not the correct variable name, right? MMT imperial. Well, that's not true. It's material thickness native, right? It's MMT native. Right? Because we took MMT, MMT in terms of lugs, lugs converted to imperial, imperial converted to native. So this is MMT native. Model material thickness in native units. So we take this and we use this to extrude, right? Okay. So let's make sure that we don't get any crashes. Okay, cool. And then so we're on the center, right? So to do the other extrusions, module ZIT and we want to do sub, and let's do sub top first. Okay, and it takes the comdex and it takes SBC, right? And also the thing is that we're not going to extrude children anymore, right? We're going to literally take we're going to do ZIT component, right, and we're going to look up the component to render, right? So we have the component index right here, right? So we're going to take the component index, we're going to take SBC, and the com actually takes something else, right? It takes the render mode, right? It takes the render mode. Yes, it takes the render mode. So we're going to have to do... It takes the render mode. Okay. So the render mode here is going to be defined in this file, right? So the render mode takes a render dex, right? So the render mode, or maybe we should have called this, you know, ren mod. Well, these are indexes, right? So maybe we should just keep it as a index, right? An index operator. Yeah, let's keep these as indexes because they're sequential. It's not the same thing as a render. Oh, whatever. So it's not going to be perfect. Let's not worry about it. So it takes a component and it takes the it takes this rendering index, right? Because it's an additive, right? So we linearly extrude it using this native units. The center is true, and this is how we look up the component, right? So F4. Okay, so now, over here, let's steal all this, and the top, we can do the same kind of thing, but let's, this is kind of annoying to have this duplication, but let's not worry about it. We're going to use... So this was the additive body, and then we're going to... This is sub top, right? So we're going to take this. It's going to be all the same code, except this is sub top, right? And so... might make sense to make a module zit ext make sense to do a linear extrude thing here, right? And just give it the, just make it like a generic helper function, right? Because there's a lot of code, there's duplication here, right? Let's just steal this, right? Let's steal this and throw it in here. So this is the linear extrude function. And by default, we'll center it, right? We'll center whatever we're extruding. And we'll extrude it by the material thickness that's fine, right? And then children will go in here. Children. And then this wrapper here, right? We'll just do linear extrude, right? Right, and we'll just be a wrapper, right? It's like all the same stuff, except, yeah. And let's make sure we didn't do anything horrendous with our syntax. Nope. Okay, cool. So they're still in good terms there. And then, right, and this is the same thing except it's sub-top, right? So we can take all this stuff and we can just say, oh, this is, you know, sub-top, right? And since this is a linear extrude function for specific functionality, we can give it an offset, right? So we can give it a relative offset and say, well, how deep into the material do you want to be? So the offset here is going to be 0, right? So we're not gonna move anything, right? The offset here is going to be, it's the top. So well, hold on. We want to know the amount to the left and the amount to the right to extrude, right? In terms of material thickness, right? Or what do we want to do? Okay, let's just make this linear extrude. Let's not get too complicated here. Okay. Linear extrude, linear extrude, linear extrude, right? And, the extrude by default is going to be the entire material thickness, and then this is going to be a scale factor. And this scale factor is going to apply to the height, because we're going to need that to punch holes all the way through here. So the native units times the scale factor, and then center is always true. I don't know if we can write the code like this. We'll find out. Okay. And now with this linear extrude with the scale factor for the body is 1, right? And the scale factor for the top is also 1. And the scale factor for the bottom stuff, also 1, right? So the bottom is still 1. However, there's different positioning here, right? So let's just keep offset for all of this stuff. So let's say LZ takes SBC, and in terms of lugs, it's 0, right? There's no offset here, right? Okay, and then we want to go let's go look at the, oh, let's not leave any unfinished, what the fuck is this? Let's not leave any unfinished code. Like, if we screw this up and we leave unfinished code, we're going to be in a world of hurt. So do not at all. Make absolutely sure this works, or at least doesn't crash on us. So, what are our shop block constants here, right? So, the model material thickness in terms of lugs. Fine. Now, the air gap we want to keep, well, actually, that gap was going to be... This is the air gap we want, right? And we want a certain... we don't want a bore depth. We want a bore left over, right? So, when we try to... So, zit so usually it's like so there's an air gap and then there's a thick gap, right? Or there's the air gap, and then there's the... the air gap is negative space, so really it's like a positive space gap, right? It's the matter gap. I don't know. Air gap, wood gap, material gap. It's the leftover gap. It's the remainder gap, right? The rem gap. Remainder synonyms. Remnant, remnants, rump, surplus, difference, rest gap. It's the barrier gap, bar gap. Or maybe it's the physical gap, right? So there's the air gap, and then there's the physical gap, right? So maybe, physical, PHY, right? Okay. So, right here we're going to say phi gap, imperial, and that equals a quarter of an inch, right? Physical gap, imperial, right? So that is the physical gap, imperial. And because of the bolt size we're using, that gap, if 0 plus, okay, there's a physical gap on one side, okay, and then there's an air gap in the middle, and then there is a physical gap on the other, there's a physical gap on the other side, Jesus. Physical gap on one side, air gap on the middle, physical gap on the other side, right? So, top wood physical gap, right? Air gap between wood. Okay, and bot wood physical gap. Okay. And we're going to expect that to be, according to our notes, according to what we've done empirically, that there is 1, 2, 3/4, 3/4, 4/4, and 5/4. So 5/4 is so 1 1/4, right? So if 5/4 not equal to oh wait, hold on. I know I did this. Zit total gap imperial equals this, right? And if 5/4 is not equal to zit total gap imperial, then echo total gap should always be exactly 5/4. Right? Because that's just empirically how things have fit together in a sensible way with the bolt size that we like to use for what we do. Okay? So we can be flexible with what these gaps are, but these two gaps here need to go together in a way that makes sense. So at vid IID 0205, and the time is 3 hours, 58 minutes, and 23 seconds. So I just want to note that, right? So this is the air gap, this is the physical gap. So the air gap is the empty space between the two panels we're bolting together, right? The physical gap is the amount of material that impedes the bolt from busting through the material that we're pinning together, right? And so since we have two pieces of wood, we have, two physical gaps, and we have one air gap between those pieces, right? So the air gap could potentially be 0, but the physical gap cannot be 0, right? So if, if 0 equals zit air gap imp, okay. This is allowed. Okay. If 0 equals the zit physical gap imperial, that's not allowed, right? Because we just don't have enough material, right? So actually, if this gap is so echo absolutely not allowed 0 gap, right? There's no material to hold it, right? There's no material to hold it if the physical gap is 0, right? Now if is less than 1/4, right? Right now it's 1/4. Anything less than 1/4 is too thin. It's too thin. It's not going to. It's not structurally sound. So echo. Danger. Not structurally sound gap. Okay. So we have all these kind of things here, right? So let's put F4. Make sure we haven't made any syntax errors. And let's right? So, gap between sandwiched wood panels. So this is the gap configuration right here. Gap between sandwiched panels. That's what this configuration is right here. Okay. So we need these variables because in order to calculate the next thing, we need to know this physical gap imperial in the extrusion settings. So in the extrusion settings, on the LZ, the lug Z, or actually the, we want to go inch Z offset, and we want to use, well actually, first of all, LZ, SBC, and we want to do, I want to take this material, so on the top, what we're going to do is we're going to we're gonna do, oh, you know what? This is my bad. 0 plus, in the components, not the components, but in here, the physical gap. So we want to offset from this. This is completely, this extrude is completely centered, right? All these extrudes that we do are completely linear extrude and it's centered. So what we want to do here is we want to do 0 plus, and we want to do the physical gap imperial. So that means we want to do inch Z offset. So that we have the physical gap we want, right? So when we use this as a boolean to subtract from the geometry of the model, we subtract the correct depth, right? Because this is the physical gap of the wood that needs to be left over, right? So without any offset, we are effectively going to delete all the way through the body, right? And so we need to do this to not delete all the way through the body, right, on the top, right? So this is, God damn it, this is the wrong fucking side. Okay, so wrong stuff. So this, so lug Z, or actually no, none of this. Got fucking, Okay, so we don't know what the fuck we're doing. So that's great. This offset. No. So we're going to formalize that so we don't screw this up. I was just going to call it children. Because I screwed this up. I don't want to screw this up. So, okay, there's no offset. There's no offset, okay? There's no offset there. We just linearly extrude it because it is the additive body, right? So this just stays in the middle, right? But then, for the top, we want to offset it. If we don't offset it at all, it's going to blast through the entire piece of wood. So we want to move it by the physical gap that stands between the bolt and the air gap, right? So there's a physical gap that stops that bolt from going through the wood. How thick is that gap? It's this thick. So we move it up, right? Now on over here, right, we want to do the same kind of thing, but we want to go in the other direction, right? So we want to go in the other direction. So this is subtracting the top. And so this is going to be a 0 minus, okay? Okay. And then we have one more thing. We have subtop. And why is this the same name here? This needs to be called subbot, right? This is subbot, right? Okay, so let's find these functions, right? So let's color code these for a second, because we just don't know what we're doing here. Right, so these colors, we're missing one. Okay, so first of all, let's just nuke this. This is distracting. Get rid of that. Okay, so now, the last thing we want to do is we're going to go ext sub pun for punch through, right? So sub pun, right, which should be this last thing, yeah, sub pun. And, right, we have subbot, subtop, and this would be sub pun, right? And in order to do this, once again, no offset, right? So there is no offset on this one. Bam, no offset. Do not offset, okay? But we want to punch through, and we want to make sure we punch through all the material. So we're going to add a scale factor to make absolutely sure that this geometry gets punched through the entire model. So we're going to do a linear extrude and scale factor with 2. Okay, so now let's make absolutely sure that everything is accounted for here. So let's color code everything and make sure that everything looks good here. So 1, 2, 3, and 4. So we have these 4 colors, and they should correspond to the additive, the subtractive top, the subtractive bottom, and the subtractive punch through. So these colors should match, right? All these colors should match, and indeed they do. So the next thing is, did we make any stupid syntax here? So, no. Cool. Okay. So let's clean this up and just condense it a little bit. Say, you know what? We don't need to see all this, right? We don't need. Yeah, but let's just condense it, right? Let's just condense this logic. This logic never changes, right? We don't need to. I'm not gonna. Right? Let's just condense some of this. Oops. Okay, so we condensed some of that logic. F4. Make sure that still works. Okay. So let's so right here is the I guess these are all the extrusion helpers, right? Extrusion helper functions, right? So these are technically this is pragmatic component invocation, right? Because we want the extruded version of this component, right? And that's all it does, right? So this thing here gives us the extruded version of a component. So at vid IID 0205, and the time is 04:10:32. Okay, gives us the extruded version of the component specified by the comdex. Right, that's all we're doing here, right? Okay. And then down here, so these are extrusion helper functions, right? So these are the nitty-gritty details, really. It is what these are. These are things that once we're done with them, We really want to never have to look at them again. Okay, save that, F4. And then, not useful in shopbot code, but good to self-document. These are useless self-documenting functions, right? That's what these are, right? They were useful in the other code that we wrote in the laser code, but useful when writing laser cutter code, but not useful for shopbot code because of the added complexities. Alright, so 0205. The time is 04:12:44. Or let's just call it 50, because that's what we'll be. That's where we'll be by the time we're done. Yeah, so I think that, right, these functions are kind of like, it's functionality that usually would be useful, these kind of helper functions, but not in the code we're writing right now because there's just too much extra complexity. Okay, so now that we have this, let's go back to, I don't know where we're calling, ignoring zip phi gap imperial. What the? So that's not what it's supposed to be called, first of all. So somewhere in here we have something called, so phi gap imperial, and at some point we're using this gap imperial and we're calling it zip instead of here we go, zit. Okay, F4. Okay, so now this zit-e thing doesn't exist, so we gotta go find that. It's probably in the assemblies, right? So looking at our assemblies, we have zit-e cob, right? And I mean, I guess we could, I guess technically we can kind of use those wrappers, can't we? Because we can do the wrapper functions for these EXTs. Just take the, it just takes an SBC object, but it wraps it with the component index and then the SBC object, right? Yeah, sure, why not? So in the assembly code, right, we're gonna call this zit-ext for extrusion, and this is zit-ext extrusion as well. Language, go here like that, and so this is the corner top, this is the corner bottom, right? And this is zit-ext mid. Okay, 4, let's see if we got anything. And we got nothing, huh? It's just blowy uppy on us, huh? So now the question is why and how do we fix it? At what point have we royally screwed up? So before we look at this, we need to kind of assess where the mistake is. So we can try this corner thing with these kind of parameters and see if we, so zitcom corner does not exist. Okay, well that's a problem. Why doesn't it exist? Because it's now called corner top, right? So that's why. And when we do corner top, well, we got that, right? Okay, so that's there. But now, what if we try to procedurally get at it, right? So if we do this, and actually, let's remove these other parameters. Does that even work, right? Because maybe that doesn't work. Maybe it's expecting other parameters. Nope, so that's still good. So my question is, if we get rid of this, right? So if we get rid of this, and instead we pass it the actual index for the component, right? So we give it the component index for the corner piece, the corner top piece, which is 1, right? And if we give it that index, does this still work, or does it fail us, right? Okay, so let's try the F4. Okay, so that still works. Okay, so if that works, then why is the extrusion code failing us? So let's try that. So zitcom zitext, right? Take zitcom dex cot, right? And zit SBC. It takes all the same stuff, right? And F4. And oh shit, so there is something there. Hold on. So in top view, we just can't see anything, but something's there, right? And if we try to render it, in trouble, right? Okay. So obviously that's not the way this is supposed to work. And the reason for that is because our component just isn't properly set up for this corner piece yet, right? Because this component piece, right? So let's look at this piece. This is the big corner, the corner bottom. And the render index isn't doing anything yet. So this is the additive geometry right here, right? So what we want to do is, let's just break this apart into the 4 different parts that we need to have, right? So, if, you know, let's go take the pieces, right? So if, rendex equals this, right? If it equals this part, then we want to do zitcom cob if we want to do addbod, right? Additive body, right? We want to do the additive body of the model, right? Or zitcom additive body of this cob thing, right? And then we'll give it the SBC, but we won't give it the rendering index because rendex, because now we don't need it, right? Okay, else, right? And let's do some else's, right? And so we have the body, the additive body, the subtop, right? So this is subtop here, subtop. And then we have personally, I don't like putting this into multiple functions like that. I think that's way too granular. So, sub pun, right? Sub punch through is what we called it. Sub top, sub bottom, sub punch through, right? So that's the kind of pieces we have. Okay. So else echo unknown rendex zitcom cob, right? Okay. So we're still gonna fail here, but hold your horses, right? Okay. So now, what I'm thinking is, I don't know, tough luck, just put it here and hope for the best. And yeah, it sucks that this is kind of so bulky, but we're just stuck with it this way. This code is just bulky. I don't know what to say. It sucks, it's bulky, whatever. Okay, so now if we do that F4, right, we should be able to see non-subtractive geometry. No? So now there's nothing. And these should be all the pieces of geometry that we're going to subtract, but there's nothing in there anymore, so why doesn't it like us? Actually, well, we could do this thing called F4. Nope. Okay, so let's go look at how we do the extrusion code. Maybe we've still screwed that up. So if we see this, we got sub top, sub bottom, right? And we union all this together. So we do a difference between this. And so the first part I'm thinking is, let's just make sure that if we do this, that we actually get the piece of geometry, right? So we get the geometry here like that. But if we try to subtract this for whatever reason, it seems to not be the index that we think it should be, right? So subtop, and we see zit component, comdex, and SBC, and the rendex, right? So subtop, right? Ren subtop. Ren subtop. Rendex subtop, right? Okay. And the component, let's go look at the component. So the component wrapper code for a second. Comdex SBC. It takes three things. And there are those three things. So this subtop thing, we comment everything out except for subtop, right? Subtop takes comdex SBC, right? And then it, we pass on these parameters. We pass them on, and it takes the it takes rendex subtop, right? Okay, yeah, that makes sense. Is it possible because we're trying to extrude something that just doesn't exist? No, I don't think that's the problem. F4, let's make sure we haven't done anything stupid so far. Is there possibly a render index that's not supported, that's not recognized? So let's look at this component for a second. So in this component, do we have the subtractive top? Echo subtop. Is this actually being executed at all? F4. Doesn't look like it. It looks like this is probably getting called twice, right? Or none of it. Or absolutely none of it. You really can't trust these echoes, though, unfortunately, right? These echoes are not... So this is corner bottom, right? We could put something here and be like, you know, corner bottom, right? And we might not actually see it, even though we know this is executing, right? So like if I comment this out, right, we'd have a problem, right? And if we don't have a problem, then we really got to think about what's okay. So that's just, so this is just complete BS. This is complete BS. I know this is the bottom model, and it's telling me right now that this is just we commented this out. There's no way this code should be executing. So, OpenSCAD sometimes just does not work very well. So let's try to render this again, right? And now, yeah, now we're not seeing anything because, yeah, there's nothing There's nothing. Yeah, there's nothing. Fucking hell, man. Okay, right? So we put this back in, right? And go F4. And... Really? 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 Do we just have to close the goddamn thing every single time we want to do this? Oh, wait. Wrong fucking file. Close this. Wrong file. We had too many files open. Okay. So, Zodiac table, let's close this. Why do we have this open? This is the thing we want to look at. Hopefully we haven't completely screwed ourselves over here. Okay, so... Okay, so we see that it's suppressing our echoes, right? It's totally suppressing our echoes because if we do this, right, or I don't know, let's close it and reopen it because it thinks that exists when it doesn't. Does it not? Why does it think that? Are we working in the wrong file? Seriously, are we working in the wrong ZIT, right? Zodiac INSET table. And we just commented this out, did we not? And if we commented this out, why is it still working, right? This is the corner bottom, and the bottom corner is the bigger thing, right? Is it not? Is it not? Let's comment this out. Let's just comment it. Let's just do that. Let's comment that out. How about that? Does it still work? Unknown module caught. Okay. So corner top. First of all, corner top. Okay. Well, our code is just wrong. Our code is just freaking wrong here. Okay. So first of all, do things in order, right? So in terms of the screen space, the top thing should be on the top, the bottom thing should be on the bottom, right? So if it's in top-bottom order in the 3D space, then it should be top-bottom order in the code. Okay, that's the first problem we have here. The next problem is that this wraps the wrong stupid thing, right? You see this thing here? This is not the corner bottom. And we know it's not the corner bottom because if we look at the code... and we look at how we did this. This is the corner, and these enumerations aren't even right. Corner, lug, whatever the heck. Right? Because we changed them, right? We changed them to corner. Let's change this to corner top, right? So let's change this. So these are going to be called caught for corner top. Okay, caught for corner top. Caught for corner top. Okay. Okay. F4. Okay. And then once again, we're going to go into the component and see this is not this doesn't even exist. How does it think that exists? Because probably that code isn't being called, right? So this code isn't being called, and that's why we have a problem. And this is the corner bottom, right? And this should be, instead of corner bottom, this should be corner bottom like that, right? And then that even shouldn't be it because this should be. Right, it's the exact same code, right? It's the exact same formulas. Exact same code, exact same formulas and all. So let's just call this corner top, right? Corner top is this function. And we use the corner top stuff. And this is corner top, right? This is corner top. So let's highlight anything that says corner top. And everything here needs to be corner top. Everything here needs to be corner bottom, right? So this should be corner bottom. So cob, corner, okay. And so we want this to be cob, and this to be cot, right? So corner, top layer. Okay. Now let's try this one more time. So cot and cob, are they in the correct sides, or do we have anything that's mixing together, right? So right here, this should be corner top. Okay, so now if we try this, things are still broken, right? Things are still broken, but maybe it's looking better. I don't know. This is the corner top, though. And was that what we were rendering? Well, I mean, it's not nuking. It's not nuking us, right? So that's good. So let's look at the extrusion code. So the extrusion code is are we trying to render? Is that what we tried to render? Yeah, we tried to render the corner top. So that actually looks good. Okay, so let's just get rid of some of the commentary now, because we were kind of running around with our head cut off, not knowing where anything was. And let's do this else if. Let's take this else if kind of stuff, and let's throw it into here, right? So this if, this is the corner bottom code. So if it's the bottom code, this is what we do. Okay, and now let's try F4, make sure we haven't introduced any mistakes. Okay, cool. So now the next thing is we want to put back in the subtractive code, right? Because we kind of started commenting things out because we were like not knowing why things weren't working. So if we put this back in, that should be okay, right? We should still see the correct geometry. Now, it's right in the middle like that, that's good. Now, we need some type of geometry in here. Like where are we gonna put the legs, right? Do we want legs kind of like in the middle, like at 45-degree angles? Well, having less material would be better, right? The less material, the less material, less problems, right? So, let's create some type of peg. Let's not worry about the exact design of this peg. Let's just worry about creating some geometry in here where we can, so this is the corner bottom, this is the corner top, this is the corner top. So look at the assembly here. Okay, well, first of all, this is not the assembly. That's why we don't have those offsets. Okay, let's put back in this assembly and see if maybe we have something where at least this corner piece kind of looks like how it needs to look. Oh boy, thingy's all blowy-uppy. So let's look at the assembly and see why that is. So ext, the extrusion functions don't work like this anymore, right? The extrusion, the ext cot, is a wrapper function. And if we look at the ext functions, I think we do have those wrapper functions. Ext cot takes just takes SBC. It doesn't take any of that nonsense. So first of all, we can get rid of this. It doesn't take the extrusion function, that is the wrapper. It takes none of that. It just takes the SBC object. Okay. So that's one mistake. ly forgot SBC. So the offsets, the offset objects, oh, you know what? the assembly zit mid. Is there the possibility that these are no longer the correct values, right? We kind of screw that up, and now no, that's there. Zit mid, right? What about this, right? Is this one wrong, right? Like, if any of these are not, if none of these are, if any of these are not, so zit corner, yeah, because it's not called corner, right? So in the assembly, right, this one transform is wrong. So this is the corner, so see, this is the corner top, right? And then this corner here is the corner bottom, right? Corner bottom. Okay, let's try that. And see, okay, so we're getting a little bit closer, right? So we're getting this kind of thing here, where we have these two different pieces. And unknown rendex zitcom cot. Component cot. Unknown rendex. Okay, so something is getting past a rendering index, and it's saying, I don't know what that rendering index is. And the rendering index, my guess is probably just null, right? So let's comment out some of the stuff that we're not done with, right? We're really not done with this, so let's just comment this out and try to focus on just these parts, right? So the rendex is still... Oh, hey, thanks. Yeah, it looks like you need... Alright, yeah. Let me know when you start streaming, because honestly, I've been streaming all night, so I'm pretty tired, right? I've been streaming all night, so, like, yeah, I mean, I can definitely take a break to just not work, because my brain's getting pretty fried, right? So, I could definitely check out your stream and see what you're up to. Because, yeah, I don't think my brain's gonna last for much longer, but I just gotta figure this stuff out. So, I'm having a lot of difficulty right now because I have a very set system. So I've made a lot of laser cut models, and I have a very set system for, I create the 2D blueprints, and then I use the code for the 2D blueprints to create 3D parts. And then I position those 3D parts in space so that I can verify that everything goes together correctly, right? So, like, once I go to the laser cutter to cut stuff, I know without a doubt that it will fit together, right? Like, I don't have to go cut it and then be like, oh crap, it doesn't fit together, better go change some things, right? Like, it always works because I'm so meticulous about this. The thing, though, is that with the ShopBot, you don't have to always go all the way through the wood, right? You can go... Maybe you're milling on the top of the wood and you're making like a borehole. Maybe you're milling on the underside and making some type of inset. Or maybe you're going like all the way through the wood, right? So there's more possibilities for what you can do because of the depth of cut. And so that adds some complexity. So I'm trying to figure out how to make a pipeline for this. And so basically I only have this basic shape here because I gotta... figure out how everything needs to go together, and it's going to take some time because I've made, you know, hundreds of little laser cutter files, but I haven't really made very many ShopBot files. So, anyways, I'm going to keep on figuring this out. So unknown rendex. So at some point there's an unknown rendering index being passed, and I don't know. It's obviously from here somehow. Now, this extrusion function, does it need a rendering index, or is that supposed to be out of the box? So let's look at the extrusion functions. The extrusion functions need a... Nope, they don't need that. They need... The wrappers take... Oh. Are these indexes proper? Are those indexes like actual indexes, or do we not spell them right, or... Nope, that's the thing. Okay. Corner top, corner bottom. Okay. So that seems to be the correct indices for that. Let's close this thing called fab. It's just distracting us. What about this? What about this corner bottom thing? Yeah, that exists. However, the extrusions, do we have things included in the wrong order? Would that create a problem? So extrusions are relying on the components. So no, that order is fine. Okay. Possibly we're not looking at all the extrusion indexes that we're supposed to. Did we make that simple mistake? So let's go look at our code again. Unknown. Okay, well, first of all, rather than this unknown first of all, the render index that's unknown, we've done a horrible job here because these function names, right? We've done a lot of cutting and pasting, right? So first of all, which one of these is coming from both? It's probably coming from both. So COT and COB, both saying that there's an unknown rendering index. So if this, if that, if that, if that, if that. So first of all, what's the rendering index, right? So echo bad rendex. I don't know, bad rendex. And then I think what we can do is we can just add the rendex as the next parameter like that and see what happens, right? So we can do that over here. And if it's a NaN value, that'll give us some information. But let's just try that. F4. Bad rendex is 3. So 3 is not being supported. Okay, well, why is 3 not being supported? This is 1, 2, and oh. There you go. Sub top. Sub bottom, and then right sub top, sub bottom. Okay, so these are the top bores, right? These are the top bores. These are bottom bores. Okay, and this is all the way through, right? That's what this is, right? And this is the additive body, right? That's what these different sections are. So we're looking at these categories here. That's what this is, and this is the additive body. Okay, so now let's look at this. Okay, much better. Okay, so let's try to add some subtractive geometry in here, right? Like, let's try to add some type of peg. And we already know what the material thickness is, right? So if we make a peg, one axis of that peg has to be in terms of the material thickness, right? So if we want things to look nice, we might want to consider making that peg just the material thickness in both directions, so that the peg hole just doesn't look weird, right? And because the material is pretty thick, that might be the best way. So let's let's not get too out of control here. Let's just do that. So let's do a on the top of the all the way through. Let's punch through the whole material. Let's punch the whole material and just do a lug rect SBC, and we'll take we want to know what the model material thickness is. We want to know what the model material thickness is in terms of lugs, right? So if we look at this, we already have that variable in our settings, right? So model material thickness in lugs is this, which gives us 5/8, right? We kind of, that's what it is. So we check the wood thickness, right? And the wood thickness here for this file, if we take the, for this settings object, if we take the thickness of the wood and in lug units and we convert those to imperial units, then this wood thickness should be 5/8. And we're passing there. Okay. So what we're going to do is we're going to take the model material thickness in lugs. We're going to take that and we're going to take it and go, oh, SBC, right? And we're going to take that configuration object, right? Here, let's kind of... So the model material thickness is going to be this, in lugs. And then we'll just make a peg that is exactly that size. And I have no clue where this hole is going to end up. Like, I don't know where the origin of this is. I think the origin is, like, here. So it's going to chip away right there, I believe. I don't know, but let's just see what happens. So F4. No dice, huh? Just nothing? Oh, wait, no. There's a chip. There's a chip. It's right there. It's on the bottom. It's on the bottom. My bad. It's on the bottom because that's the piece of material. Okay, fair enough. So, I don't know if the origins for where we're putting things make sense. But let's just... But we know it's at the origin. The origin is kind of like right here, right? So we can work with that. So let's just move it, right? Let's do a diagonal move, and let's move by how about MMT divided by 2, right? So let's move all the way in, right? If we move all the way in, then it's gonna chip off. It's still gonna be. It has a perfect tangency now, right? Which is horrible, but we're getting somewhere. Okay. So now with the perfect tangency, well, how do we make it into the middle, right? So instead of doing this, how thick is this material, right? It's knowing how thick that material is, well, here's the thickness, right? So if we go by the thickness divided by 2, then then it should be exactly in the middle of that material, right? Should it not? Yeah, right there, right in the middle. Now the problem with that is it looks like this whole, if we put it in the middle of this material, it's not going to be, we really want to be in the middle of the thin material, right? So, we're just gonna say, you know, thickness of thin, right? And we're gonna say thickness of thinnest component. Or something like that. I don't know what we want to call it. Right, but we want to use this thickness. And We'll just call it thick of thinnest, right? Thick of thinnest. And then we can do the same thing in the other model over here, right? So this model here doesn't have any punch all the way through geometry, right? So we can paste this here, and then we can also grab this thick of thinnest, right? We'll grab this over here, and we'll put that like that. So thick of thinness. However, we need some other variable, don't we? We need the model material thickness, right? Copy, MMT. MMT is being used here, right? Yeah, because we were making the peg. So we gotta grab that as well. So we have lawn thick MMT and tot, right? Lawn thick MMT and top. Maybe we should do it like this, right? MMT is kind of a dynamic variable, so maybe we want to put it at the top like this. And maybe we want to reorganize our process here, right? Organize that. Okay, so let's try that. F4. Okay, cool. So now we have a hole all the way through everything. Now this hole is not appropriate because it needs to be rounded, right? It needs to be rounded because the shop bot can't do this kind of interior hole, right? The shop bot needs a rounded hole of some sort. So if we want to have something like this, then it needs to have like it needs to have artifacts from the mill, right? It needs to have some milling artifacts. So we can there's a lot of ways we could do this, right? To get that kind of square shape, like we could there's plenty of ways we could mill that out, right? We could do some type of radial pattern. We could do some type of radial pattern, which would be kind of cool. We could do kind of a radial pattern actually might be the best. We could do something where we make it completely bilaterally symmetrical, where we do like 45, where we cut in at a 45 degree with the mill to get rid of that extra space. What if we oh, that might be a good thing. The other thing we could do is we could just file it, right? We could file it, right? Instead of, We could file out the corners manually. I don't like that idea, though. I think we need to get something working first, right? Let's get something working. And then we'll worry about that aspect. So it's a 1/4 inch end mill that's going to be used, a 1/4 diameter. So when we're thinking about the size of the holes here, right, that needs to be considered when we're rendering this stuff, right? And that should be in the... No, do not reload. Do not reload. Don't tell me it's wrong, because it's probably correct. It's probably OpenSCAD trying to nuke my file. Okay, so let's so let's go into here, and let's go into here for a second, right? So we have lugrect. Let's go find lugrect for a second. And we're going to have to make a thing called, like, lug peg. Lug peg for, like, a lug peg hole. And well, we have V-carve pocket, right? So V-carve pocket is not the same thing as a lug peg, though. Let's do or we could give it, if the rect needs to have roundings, then we could do let's make a thing called peg artifacts, right? Let's say peg artifacts, and you know, if peg artifacts is greater than or equal to 1, then blast right, so we're gonna just blast out those corners. If it has artifacts, and so we're just gonna say that we can do lug xy, right? SBC 0 plus nat width divided by 2. 0 plus nat height divided by 2. Right? And so this is the positive, right? Well, first of all, if we're doing log xy, my bad. I just want to do log width divided by 2. Okay, and then yos, y offset, equals the log height divided by 2. Right, so we want to go halfway on each axis. And 0 plus x offset, 0 plus y offset. And then we just want to create a circle. So our circle, oh, alright, I'll check you out. Let's, let me put on my break timer here. Alright. Maybe like 20 minutes. Okay, I'm gonna stop the stream so I can see if I can hear my friend's stream or not. I'll be back.